rounder again, we can process that data in near real time. We can track targets out to a range of 100 meters and closer. And then maybe once we're sure the target's getting really close, we turn on something that's really high bandwidth that we can't process easily, like an optical camera, and we collect information right when that fish or marine mammal is right at the device. And that's a way that we might go do something of a more selective duty cycle. So rather than collecting information continuously and trying to, in post-process, using only that data stream to filter out what we want, maybe we can use all these different sensors working together to try to turn the high bandwidth ones on only when they're likely to record something. So that's the workshop outcome. I like to say we're a little ahead of the curve at UW. Part of the reason was we were involved in the workshop, so we got to shape the outcome a little bit. But we've been thinking about something called an adaptable monitoring package, or an AMP. I generally hate acronyms, but we're working with a utility on this project. Utilities love acronyms. They said, you need an acronym for this. I said, well, if we're doing a renewable energy project, we should pick an acronym that reminds us of power. I tried to get to ampere, but it was a little too contrived, so give an AMP. This is a project I'm working on with some collaborators at APL, Andy Stewart, Ben Rush, and Paul Gibbs, as well as one of my grad students, James Joslin. This is the AMP. So the AMP is an integrated package that can support many different types of instrumentation. So we've got stereo optical cameras, which are illuminated by a quartet of strobes. We've got an imaging sonar. We've got a smart hydrophone. We've got a cetacean click detector. And that's all environmental monitoring. And then we've got things like a Doppler current profiler to look at turbulence and how that's interacting with devices. And we've got a Doppler velocimeter. And despite Andy and Ben and Paul's desire to make this as small as possible, we keep preserving space so we can add more things down the road as we decide we want to add these in. So here's an example of an integrated package that we've already been developing. Now the problem with this integrated package is that you start looking at the data and power needs